Okay, I'm wondering what the largest number is that goes into 12, 20, and 32. And by number, I really mean integer, because on all of these, we're going to be dealing with integers, so not fractions and decimals and things like that, but just basically positive and negative counting numbers. So, with that in mind, I'm looking to see what the largest number is that goes into 12, 20, and 32. And you might already know what it is, and that's fine if you do. That's fantastic. But even if you know that the answer is 4, I'm going to walk you through the process because sometimes you get into crazy ones where it's not always obvious. Like, for example, in my opinion, the hardest one on the paper is this. And you might be able to look at it and tell exactly what it is and maybe not. Or even this. This one's slightly tricky in its own way. So here's the deal, and this is my quick little way of explaining it. If I had 12, then I could break it up into 2 times 6 or 3 times 4, but I'm gonna go with the prime number first just for consistency, and then 2 times 3. So all of these are prime. There we go. And then 20 is 4 times 5 or 2 times 10, and 10 is 2 times 5, and there's your prime numbers right there. Factor trees, we've done it. 32, or you've done it. 32 is, let's not go prime, let's go 4 times 8. That's 2 times 2. That's, let's skip a step. This is 2 times 2 times 2. So 2, 2, 2, 2, 2. And so I want to know the largest number that goes into all three of these. And if the numbers aren't, if you can't easily identify it, then this might be the best bet. So here's the deal. Let's look and see what they all have in common. Well, they have a 2 in common. Okay. Let's mark that out. Let's just put that. We're going to put a 2. Now, that's not the final answer. And then we're going to keep going. What else do they have in common? Oh, they have another 2 in common. And so 2, 2, so that's going to be 4 in a second. We multiply, not add. And what else do they have in common? Oh, that's it. So it's 4. Now, a lot of that can happen in your head, and hopefully so. But again, if the numbers are kind of crazy and hard to deal with, then this might be your best bet for doing it. So break it down into its prime factors. So now we get to the largest factor that goes into 12x cubed, 20x squared, and 32x. And if you wanted to, we could go through this same process, and we're not. But here's what I do know so far. I know it involves a 4, and I know it involves a 4 because we're dealing with 12, 20, and 32. 4 goes into 12, 4 goes into 20, and 4 goes into 32. So with that in mind, now we have to deal with our x's, and so I have x to the third here, so I have x times x times x, and here I have x squared, and that's x times x, and here I have 32x, and that's just x. Okay, if you wanted to, you could say that this is, I'm going to go with it because I just feel like it. We could say this is 2 times 3 times x times x times x. That's what this is. And then we could say this is 2 times 5 times x times x times, well, that's it. And then this is 2, 2, 2, 2, 2. All those are prime, and then we have an x, and we're going to split them up. So then when we say, oh, what do I have in common? Well, I have 2's, and I also have, let's see, I have an x. They all have an x in common, and okay. Well, what else do they have? Well, that's all. That's all they have in common. It's just a 4 and an x. So 4 goes into all those, and then they all have an x. Well, let me give you kind of a shortcut. Nah, let's not. Let's let you discover it. So largest factor that goes into 15, 20, and 30. So let's ignore the variables first, and let's do the numbers first. So let's go 15, 20, 30. Let's see. Now I know the answer, and you probably do too, but I'm going to tell you what it's not. I'm going to walk you through your thought process, possibly. So if you're just looking at these two, it'd be 10. But then you say, well, does 10 go into that? Well, no, it doesn't. Well, okay, it's got to be less than 10 then. So we can take half of that just because we might want to try that. And so 5 goes into that, 5 goes into that, 5 goes into that. And sure enough, 5 does. And if you factored these, if you wanted to, you could, and I'm going to very quickly. We would have, let's see, 15 is 3 times 5, and then we'll x cubed y squared. That's 3x's and 2y's. Okay, so there's the first one. And then we have 20, which is 2 times 5, and x squared y, so I have a couple x's and a y. And then we have 30, which is 2 times 3 times 5. There's your 6 times 5 right there, x y squared. Okay, so here's what I do know so far. If I'm looking to see what they have in common, see, there's your word, then I'm looking for what they have, well, in common. So there's a 5. What else do they have in common? Oh, they have an x in common. So we can mark out an x on all of them. There we go. And they have another x in common? Oh, no, they don't. What about y's? Do they have a y in common? Well, that one has a y, that one has a y, that one has a y. There we go. Are there any other y's they have in common? Oh, no. Well, these two do, but this one doesn't have another y to give up. And these two have some x's, but that one doesn't have another x to give up. So this is my greatest common factor. So when finding the GCF, there are a couple things to keep in mind. So we're going to deal with two separate components of it. We're going to deal with the coefficients. So for the coefficient, that's the number in the front. For the coefficient, find the largest factor, the greatest factor. And for the variables, take all right, let's pause for a second before I finish this sentence. Okay, so we had 5xy. So I'm looking, I have x cubed, I have x squared, and I have x to the first. I had to take the lowest one. So basically, if I walked up to these three and I said, give me all the x's that you can, well, if I want to get the same amount from all of them, then this one can only give me 1, this one gives me 2, and this one gives me 3. So since this one can only give me 1, I'll only take 1. If I say, give me all the y's you can, but give me the same amount, well, this one can give me 2, this one can give me 1, and this one can give me 2. So since he only has 1 to give me, all I get is 1 out of this deal. Or same thing here, 3, 2, and 1. Well, I could only take 1. So we're going to take the lowest exponent. For the variables, take the lowest exponent, and we'll do that for each variable. Okay, so we're going to factor these, and basically we're undistributing. So I'm looking to see what goes into 6 that also goes into 8. This one is fairly obvious, I think, and so I'm not going to spend too much time walking you through the thought process. But let's see, they're both even, so we'll try to. And if your mind goes there, that's cool. You could say, 4 goes into that. Well, 4 doesn't go into that, so, it's just 2. So 2, fantastic. For the coefficient, find the largest factor. Got it. For the variables, take the lowest exponent. Well, x cubed, x squared, well, then it's x squared. All right, so now we're going to undistribute, and the way I'd explain it is this. So we have a couple terms here. Excuse me. Basically, if I was to distribute 2x squared to this, I'd get that. So 2 times what gives me 6? Well, that'd be 3. And then x squared times what gives me x cubed? Well, it would be x. And here's the trick. 1. Because 2 plus 1 is 3. And it kind of makes sense. All right, so 2 times what gives me negative 8? Well, that'd be negative 4. And x squared times what gives me x squared? Well, that would be 1, so there's no need to put it. Not in this case. We already have something holding its place. If you distributed this, if you were like 2x squared times that, you'd get this. 2x squared times that, you'd get that. All right, let's do it again. Well, whenever you do this one, I'll go ahead and tell you, you're going to have a GCF, a greatest common factor in the front, and then you'll have 3 terms. There we go. And I know that because, well, I have 3 terms. So I'm looking for the greatest common factor between 6, 8, and 2. So what goes into 6, 8, and 2? Well, 2 does. That's okay. Sometimes the greatest common factor is one of the answers, one of the terms themselves. All right, let's take the lowest exponent. 3, 2, and 1. Well, the lowest exponent is, well, 1. All right. 2x times something would have given me 6x cubed. That would be 3x squared, because the 1 plus the 2 gives me 3. All right. 2x times something gives me 8x squared. That would be 4. It's negative. X to the how many? Well, just 1, because I'm not insulting anybody's intelligence here, but 1 plus 1 gives me that 2. All right. 2 times something gives me 2. Must be 1, and I do need that to hold its place. X times what gives me x? Well, 1. I don't need another one, and it is positive. A lot of people miss that term right there. Notice that number 1 and number 2 are kind of the same, only I threw in an extra term here because I wanted you to know that you need that 1 here, because if I distributed, I would need that 2x to show up there. All right, let's move on. So we're going to have a trinomial, blank, blank, blank. And we're going to have probably a number and probably an x and probably a y and all kinds of stuff. So let's go one piece at a time. I need the largest integer that goes into 6, 5, and 2. 6, 5, and 2. Let's see, 6 and 5. What goes into 6 and 5? Well, 1 does. That's not helpful. What goes into 1 and 2. Well, 1 does. That's it. So 1 is the only thing that goes into them. I'm going to write down the number 1 because it's nice to hold its place, but we don't have to. All right, now we look for x's. 3, 2, and 1. We take the lowest. 1. Y's. 1, 2, and 3. We take the lowest. So basically, here's the deal. For every one of these terms, we are going to lose a x and lose a y. And the numbers really won't change. Because if I said this times that gives me that, well, 1 times what gives me 6? It must be 6. And then it was cubed. Notice the fingers. I have 3, and then I lost 1, so now I'm down to 2. And again, not insulting anybody's intelligence, but just, keep in mind that if you're looking at this and this, then you're going to subtract to get that. So then 1 minus 1 gives me, well, 0, so don't even put it. All right, and so minus 5, because 1 times 5 is 5. And then 2 minus 1 is 1, and 2 minus 1 is 1. There's my understood ones. You don't have to put them. All right, plus 2. 2 divided by 1. And then 1 minus 1 is 0, so it's gone. 3 minus 1 is 2. All right, let's speed this up just a little bit, because at this point I think we have it. Some of the ones at the bottom are not horribly tricky, but I threw them in there just to mess you up if you weren't careful. Okay, 45a cubed b squared minus 27a squared b cubed plus 90a squared b to the fourth. What? All right, well, here's the deal. We know we're going to have 3 terms. So blank, 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 blankety, blank, 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 blank. There we go. Parentheses with 3 terms, and we have something in the front. So what goes into, let's do 2 at a time. What goes into 45 and 27? Let's see. That is, now I know the answer, but I'm pretending like I don't. And you can go through this process if you like. I'm not going to, but you could. Let's see, what goes into 45 and 27? 3 does. Is that the biggest? No, 9 does. Okay, so 9 is the biggest thing that goes into that. So now we have a 9. 9 and 90. Does 9 go into 90? You bet it does. There it is. And that might have been what went through your head. It might not have been, but that's my thought process at least. All right. Take the lowest exponent you see for each variable. A to the 3, 2, 2. That'd be a 2. B to the 2, 3, 4. That'd be a 2. And let's do this quickly. I'm going to do this one slightly differently. Let's go numbers first. 9 times what gives me 45? Boom. 9 times what gives me 27? It's negative 3. 9 times what gives me positive 90? That'd be positive 10. Okay, so we have our variable, our coefficients. And so now, for every one of these terms, we're going to subtract 2 x's and subtract 2 y's from our exponents. So, a's and b's, sorry. Subtract 2 from that, subtract 2 from that, it's gone. Subtract 2 from that, it's gone. Subtract 2 from that, it's b. Subtract 2 from that, it's gone. Subtract 2 from that, it's b squared. And if you wanted to check your answer, which isn't a horrible idea, you could distribute. And if you did, you'd end up here. Real quick, I'm going to do it. 45, a to the third, b squared. Boom. Negative 27, a squared, b to the third. Yep. 90, a squared, b to the fourth. It works. Let's go even faster. Okay. What goes into 6 and 30? 6. Sometimes it's the number itself. All right. Does 6 go into 15? No. All right. Let's back up. So what goes into 6 and 30? 6. What goes into 6? That's the GCF between these. What goes into 6 and 15? 3. There we go. Take the lowest exponent. Don't let the huge exponents throw you off. Don't panic. What goes into 6, 30, and 15? It's not a question you should ask yourself when you're dealing with the exponents. Take the lowest. There we go. Blank, blank, blank. Numbers first, just for fun. 6 divided by 3 is 2. 30 divided by 3 is 10. It's negative. 15 divided by 3 is 5. All right. 6 minus 6 is 0, so it's gone. 30 minus 6, not 30 divided by 6. That's why I put this problem in here, just to throw you off if you're not careful. 30 minus 6 is 24. 15 minus 6 is 9. All right? It's okay to have huge exponents. It's rare, but it happens. Okay, next one. What goes into 12 and 13? 1. Now, if you say nothing, then that sounds like you're dividing 0 into something, and that's illegal. But technically, 1 goes into 12 and 13. So, well, 1. It's just kind of pointless, so I'm not going to write it. Now, let's take the lowest exponent. That'd be a 12. Okay. Well, x to the 12th times what gives me 12x to the 13th. Well, okay, let's do that just because. 1 times what gives me 12? It's 12. X to the 12th times x to the what gives me x to the 13? That'd be a 1. 12 plus 1 gives me the 13. All right, let's move over here. Minus 13, because 1 times 13 is 13. And then x to the 12th times x to the what gives me x to the 12th. It was like, what? Okay, here's the confusing part if you're not careful. If you subtract 12 minus 12, you get 0. So we're done. All right, 2 more. 4 terms. This is a quadrinomial, if that's even a thing. What goes into 8, 8, 8, and 16? Well, what goes into 8 and 8? 8. And what goes into 8, 8, and 8? 8. What goes into 8 and 16? 8. X to the how many? 1, 2, 3, 100. Take the lowest. 1. All right. Do not lose that term. Some people are like, well, 8x and 8x, well, it's just 0. No, it's 1. 8x times what gives me itself? 1. 8x times what gives me 8x squared? Well, 8 times 1 is 8. X times x is x squared. You can leave that one off. Believe a will. Thank you very much. 8 times what gives me 8? 1. X times what gives me x cubed? That'd be x squared, because the 1 plus the 2 gives me the 3. All right. 8 times what gives me 16? 2. X to the first times x to the what gives me 100. Okay. Well, if I'm adding the exponents, 1 plus 99 would give me 100. All right, last one. Blank, blank, blank. What goes into 14, 16, and 18? 2. Just 2. All right, let's take the lowest exponent of each variable. 2, 1, looking at the y's. 2, 1, 0. Can't use any y's. All right, let's look at the x's. 0, 1, 2. I don't have any variables in my GCF. That's okay. So, 2 times what gives me 14? 7 y squared. 2 times 7y squared gives me 14y squared. Wouldn't you put a y here? No. This one doesn't have any y's to give me. Wouldn't you put an x here? No. This term doesn't have any x's to give me. All right. 2 times what gives me 16? That would be 8, and then an x and a y. 2 times what gives me 18? That'd be 9, and then x squared.